Hi folks, welcome back. This video continues our discussion of informal proofs where we consider the counterexample. Your first job is to assess this argument. So I have an argument on the screen, read over these premises and decide whether you think the argument is valid. And then next, give a proof to defend your answer. So pause your videos and do this now. Okay, that was your last chance. This proof is indeed invalid. It is not a valid argument. So before we saw how to prove that arguments are valid, now we need to talk about how to give a proof that an argument is invalid. Proofs of invalidity are all going to go the exact same way. They are called the method of counterexample, or they use this technique called the counterexample. What a counterexample is it's a specific sort of scenario in which the premises are true and the conclusion is false. Because remember, if an argument is valid, then this is impossible. A valid argument cannot have true premises and a false conclusion. A valid argument preserves truth. So if we can actually show the premises could be true while the conclusion is false, then that precisely shows the argument is not valid, which is what we're trying to do here. Now, when we do that, when we explain this in English, we are giving an informal proof because all informal proofs rely on a natural language like English, and formal proofs are going to be a totally different thing that we'll look at in coming lectures. So what is a counterexample? It's a kind of skill that we want you to acquire. It's a demonstration that arguments are invalid. That's what we do with it. Okay, so let's see how this would go in the case that we were just looking at. Here are 5 premises. The first thing I need to do, it's just like a game and you have to play around with these premises. I just start constructing a scenario and then I'm flexible. I'll change it up if I need to. So I have 4 cubes, so I just named my cubes A, B, C, and D. Now, each cube is of a solid color, blue or yellow. Okay, I'm gonna hold that. So I'm gonna start coloring these things soon. A is yellow, B is blue. Okay, so now I'm gonna make A yellow and B blue. That's where I've got my drawing started. I'm filling in the details. D is on top, A is on bottom. Okay, I already arranged them that way. Now B is directly under D. Okay, great, I can do that too. So far my picture is consistent. I've made sense of almost all these premises, except number 2. I still need to fill in a color for C and D. But the key is you have to do it so that a yellow cube is on top of a blue cube. The conclusion is false. So I can't put a yellow cube up here. I have to make D blue. And then C, I can make C blue or yellow. It doesn't really matter. But notice what I've done. If I fill in my picture this way, then my premises are all true and my conclusion is false. I've shown that this is possible to have true premises and a false conclusion by giving you the little picture. This picture demonstrates it. Now, sometimes we actually talk about the picture being the informal proof. But on the other hand, technically, all proofs are explanations. And this picture, it might be a good enough explanation in the context where we're just leaving the actual proof as unstated. But really what you want to do is state in English explicitly for your audience what's going on here. So remember, all proofs have to start with the word proof and end with the word done. And when we do this proof of invalidity, we just say proof by counterexample. And my little picture here just shows the premises are true and the conclusion false. So it's got to be invalid, and then I'm done. So if your picture is good enough, then it's quite obvious. Sometimes proofs could be much more complicated. Even proofs by counterexample can be much more complicated, and more explanation is needed. But that's all that's needed here. So just remember, proofs by counterexample require a specific scenario, and that's why pictures are really helpful in counterexamples because a picture makes concrete the things that you're talking about. Okay, let's practice. Let's give you another one to do. So assess this argument, decide whether it's valid or not, and then give me a proof of it. So pause your videos now and do this task. Okay, we're gonna talk about the answers. So what's complicated here, I was trying to trick you a little bit. I think it's quite reasonable to say that this argument is actually valid. You're not supposed to give a counterexample because this is a valid argument. So I didn't want you to just sort of be falling asleep here and not paying attention and using your head. So what you could do is give me a proof that this argument is valid. I think if that was your reaction, then you're thinking about it this way. Okay, we know there was a bank heist, somebody's guilty, and it's at least one of these folks, A, B, C, or D, maybe more of them, and no one else was involved. So it could just be some combination of those 4, one or more. Now, let's consider each in turn. So this is how we would prove it's valid. We know A, B, C, or D is guilty, and so let's first consider, what if A is guilty? Can I prove that D is guilty in every possible one of those scenarios? And if so, then D would have to be guilty no matter what, and my proof would be done. So technically speaking, my proof isn't actually done here. This is just sort of a proof schema. The explanation would be much more involved than this. Let's talk about it. What if it's A? Well, A can't drive. So, and they fled in a car according to premise number 1. So that means if A is guilty, B, C, or D has to be guilty too. And what I need to show is if A is guilty, D has to also be guilty. Well, what if it is B? Because one of these other folks have to be involved. Well, if it's B, they look at premise 4, then D is guilty in that case too. What about if it's C? What if A is guilty, but then C is the one who drives the car or something? Well, if C is guilty, then could D be innocent? Could it just be A and C alone, for example, or maybe C alone? And this is where premise number 6 comes into play. What if C is guilty? Could B be innocent? The answer is no, because if C is guilty, if B were innocent, C would have to be innocent too, according to premise 6. So if C is guilty, B would have to be guilty. B can't be innocent, but that means D would have to be guilty. So if you think of, if you could keep track of all those things I was saying in your head at once, no matter who is guilty, A, B, or C, D has to be guilty in all of those cases as well. And of course, if D is guilty, then D is guilty. That's the conclusion as well. So in no matter which case it is, D has to be guilty. So this really is a valid argument. And that long convoluted explanation I gave you is the proof. Of course, that was only a good proof if you could follow me. So that's why it's actually quite helpful to write these things down, because it makes it easier for your audience to follow. Now some of you might be shaking your heads because I think there's a different answer here that's also good. You might have said this argument is invalid. See, this is the trouble. When we're giving arguments in our everyday lives, we often have unstated premises. And I don't actually want to tell you that this is a defect of everyday reasoning. It's actually an important part of our lives that we don't bother to spell out absolutely everything. It saves us a whole lot of time and effort. It's not a bad thing. But what it means is when we're trying to decide whether this argument is valid or not, we have to be explicit exactly what we're leaving unstated or what we're actually assuming. We can't just leave it unstated anymore. We need to state those things. So if your audience, if somebody gives you this argument and asks you, is it valid or not? What you should say is, well, wait a minute. Are we assuming that they had to drive the car, for example? For example, what if it was a self-driving car? What if A has like one of these self-driving Teslas or something? Then maybe A did do it alone and they escaped in a car. So the premises are all true. And this, look, they're just dozing along, which you're not supposed to do when you're driving self-driving cars. So this scenario, this shows that it could have been A alone without D. So partly it's a question of what was the person giving the proof presupposing? Were they presupposing that this was a traditional car and one of those 4 people drove it away and it wasn't A, therefore A couldn't have done it alone. These other folks must have been involved. And if that's the case, D really is guilty. So whether this is like a traditional car or not is the unstated issue we need to resolve before we decide whether it's valid. So if you were assuming that unstated premise and you gave the argument that it's invalid, then great. If this is a traditional car, the argument is invalid. If we're not making that unstated assumption, then the argument is invalid. And let me just, I might have just misspoken. I'm sort of confusing myself. If we make the assumption that this is a traditional car, then the argument is valid, and this proof is actually a good proof of it. So if we make that assumption, the argument is valid, and that's a good answer. If we don't make that assumption, maybe this could be a self-driving car, then actually the argument is invalid, and this would constitute a good counterexample of it. So there's 2 lessons here. One is when we assess an argument, we have to actually be clear on what assumptions are being unstated or not. We have to state the unstated assumptions, because only once we do that can we really resolve whether the argument is valid or not. And then once you decide, you get all the premises in the clear, then when you assess whether it's valid, if it's valid, you give a proof of validity. If it's invalid, you give a proof by counterexample. Okay, thanks.